السلام عليكم. إلا كان شي حد يسمعنا يكتب كومونتي شي حاجة yes or no or hello. كتسمعني؟ اللي كيسمعني عافاك يطابي شي حاجة. نايس نايس. ان شاء الله اليوم غادي الموضوع غيكون بلونجلي. وغنهضروا على شنو هو SELinux or security enhanced Linux in Android. نتمنى انه كلشي يكون مزيان. Okay, let's start by a small presentation. If you can present yourself, Victor, please.
Yeah, thanks, Jeff. Hey guys, my name is Viktor Lapin. I'm from Moscow. I'm the head of mobile development unit in a company named Advantum, and I would like to talk about SELinux today. So the very first question that would come to your mind would be, what is SELinux? SELinux stands for Security Enhanced Linux, and despite the name, this is not about Linux distro. SELinux is a kernel-level security framework that was originally created by the National Security Agency of the United States to protect government computers, but then it got open sourced and eventually has made its way into the upstream Linux kernel first and to the Android later. SELinux can run in two different modes. The first one is permissive mode. In this mode, SELinux will log every potential violation of security, but it will still allow everything. So this mode is pretty much ideal for development and debugging stuff. And the second mode is enforcing mode. This is the default one. In this mode, SELinux will log all security threats as well, but also it will deny dangerous operations. And to check whether or not the operation is allowed, SELinux is using the rule set that goes with the name SE policy. We will see about that in a bit. Brief history check. SELinux was first introduced in Android 4.3, and it was fully permissive in that time. So the developers were given time to learn about the upcoming changes, to adjust to it. And Android 4.4 KitKat was released with some security-related changes. The essential parts of the system were switched to enforcing, but the rest of the system was still permissive. And since Android 5 Lollipop, the SELinux runs fully enforcing in our phones, in our tablets, and so we have to actually live with it somehow. The next logical question would be, who needs to know about SELinux? Well, the short answer is, as soon as you start dealing with system partition, you have to understand how SELinux works. So if you're a phone manufacturer, if you are writing a ROM for any kind of mobile device, so you're building your own ROM with some pre-installed apps, you have to understand how it works. If you're a custom ROM developer, which basically the same thing, you also have to know how it works, maybe to some lesser extent, but still. And app developers, I think, should also know about it, but just as a bonus, because if you just create apps, if you publish them to the Play Store, they will just work out of the box, and you won't have to deal with any kind of platform security. And again, I will try to show you why in a minute. Now to the serious things. How does it work? Let's assume that we have some process that is trying to perform some action. For the simplicity, let's say that we're trying to read a file. When we're attempting to read a file, before we actually succeeded, there will be two security checks. First one is the DAC. All familiar Unix permission stuff will go here. So that read, write, execute pattern, it's all about the DAC. Then this is the first security check. If everything is okay with it, then the MAC will come into play, and this is the SELinux part. So there will be a check whether the calling process is actually allowed to access the file that is being called. Again, if everything is okay here, we will get our data successfully, no errors, no warnings, no anything. But if something went wrong, we will see a denial. Interesting moment here. Let's imagine that we have rooted our smartphone. For example, I still do that. And if we will take another look at this diagram, but with root access in play, we can actually see that it will change this way. So the super user privileges will allow us to bypass the Unix permission system, because root is the super user, so it can read any file with literally no boundaries and so on. But SELinux will still be intact, and it will still make its check. It still can deny us the access to file that we want to read. Now to the even more serious part. When we're talking about SELinux, we have to keep in mind that it's all about the labels, because every system entity has its own security label. Every file, every folder, every process, every file system in general, every system property, every port has its own security label. We can easily have a look at it by opening the terminal emulator app on our phone. And if we run the usual ls command with -z flag, we can see that every file system entry in the listing has a security label attached to it. So when your phone is booting up, the SELinux will load the policy and label every entity in the system with its own security label. The same is correct for the ps command. As you can see, I have launched the ps command, and I see two processes here. One is my shell, and another one is the actual ps binary that is being executed right now. Again, you can see the security label attached to every process. you can see that they're both untrusted apps. They're both labeled as untrusted app. And that is because I have launched shell and ps command from a third-party terminal app. So the answer to the earlier question about my app are just working without any knowledge of the platform security, this is why. Every third-party app that you are downloading from the Play Store will be labeled with untrusted app security context. And despite the name untrusted, it actually has many permissions. So it's completely transparent, and you don't have to worry about SELinux if you're dealing just with Play Store and user apps. Let's dissect the security label. It might look a little complicated, but actually it's pretty simple because most parts of it are constant values. You can see that it is column separated. And the first part indicates a user. This is a constant value. It will always be just you, so you don't actually have to worry about it too much. The same goes for the second part. It's the role. It will be R for processes, and it will be object R for well, literally everything else. The next part, the untrusted app part, is the actually important part, because this is a type of the security context. SELinux will need to check this part in its policy to allow or deny any operations. The next part is sensitivity. Again, this is a constant value in Android. It can change in the Big Brother Linux, but we don't have to worry about it. And the last part, the C part, is completely optional. It relates to the multi-level security because even in SELinux, there are different layers of security. But this is a pretty complex topic. It is surely outside of the scope of this talk, and I will not cover it today. I will just say that it is totally up to phone manufacturer to place those C parts in the security labels. To be able to perform a check if an operation is allowed or denied, SELinux needs to know the following things. First one is the calling context. So that type part of the security label of the process that is trying to perform an operation. Next, it needs to know the security context of the object being called, which is kind of logical. And the last part, the SELinux needs to know the actual operation that our process is trying to perform. This operation should be allowed for these two contexts. If your system policy doesn't have allow rule for this operation and those two contexts, it will be denied with some kind of exception and a warning or error in your system logs. All allowed operations, also called rules, are stored in type enforcement files. There is a separate folder in platform sources in OSP where all the .t files are stored. They're actually plain text files. You can open them, read them, learn from them. It is totally encouraged. And all that rule set, the whole rule set, is compiled into a binary file that's called SE policy. Now the second question. When do you actually need to create a new policy because the OSP rule set is pretty extensive actually, but there are some pretty clear indicators that you have to write your own. For example, if you have a process being spawned from init, you definitely need to create a new policy for it because no process spawned from init can be run with init security context. If you see that generic default policies like init, like platform app for system apps, or untrusted app for third-party apps, if you see that they're not enough for your needs, this can be a clear indicator that you need to create a new policy. If you see some generic denials in your logs, like denied access to default something, like default service, default prop, default anything, again, this can be an indicator that you need to create your own policy because you have to label your prop or your service with your own security context, and then write a policy for your app to be able to access it. And the last part, if your sources can be compiled because they hit never allow, I will get to never allow a little later, then of course you have to do something about it, because if your ROM can compile, well, just well. And at this point, let's get more practical. So I think it's enough theory, time to do something. Let's try to create a policy for some imaginary app. We should indicate that it's an app. Let's assume that it needs to create files in internal storage of our phone, that it has to get the current location of the phone, and also that it will need to perform some network requests. So this is pretty much the basic needs of some random app. And let's try to create a policy for it. But first, the pro tip. It's better, it is considered a good practice if you use macros, because LSP has some very handy files which are listed here that contain some kind of logical grouping of SE policy rules. So instead of writing the boilerplate code by yourself, you may just use those macros, and your code will look more clean. Okay, so let's create a new plaintext file named myapp.te. It is, again, considered a good practice to match the file name with your following type name, though it isn't required. So you may name your files as you wish, but still it is considered a good practice. Let's start with declaring our type. This is pretty simple line. We're declaring the new type for SELinux, and we also place the generic type named domain as its parent. In SELinux, you can have only one parent of a type, but you can mark your type with some attributes, and we will get to that in a minute. Next, let's use some macro, app domain, for example, to indicate that we are writing a type for some app. Again, if you're curious, you can have a look at OSP source code. You can find this app domain macro, and you can see what's going on under the hood there. Next, let's grant our app access to the phone storage. So this is your typical SE policy allow rule. It starts with keyword allow, then we're writing our type, and then we are writing the target type. So in this example, the storage of our phone will have SD card FS as the default security label for files and folders that are stored there. And again, we're using a macro to assign all the necessary permissions for files creation in that SD card FS context. Keep in mind that the file and the folder are a little bit different for SELinux. So with this line, we're actually allowing our app to create files. If we want to also grant it permissions to create a folder, we should add another line, and notice that they are different in the second part of the target context. It is called class, because if you have different entities labeled with the same security context, you need to specify what class exactly are you trying to allow something. And this we're using another macro as well. So with these two lines, we have actually granted our app access to internal storage. Next thing we need to do, we need to grant our app location access. So first, we will use another macro to indicate that our app will bind to some system services of Android. And then we should allow our app to find the location service in this example. Again, there will be any other system service here instead of location, and it will differ only in location service part. All other parts will be the same. Also keep in mind that every time you write this line in your code, so every time you're getting a system service from Android context, there will be this check under the hood. So your app that you're writing should be allowed to find this particular system service. And the last part, let's grant our app permissions to create UDP sockets. This is actually a real-world example. I've used these rules in one of our production apps. And this app needed to synchronize the time from Google servers. So this is really network request rules. And we also need to allow our app to connect to a socket, to different sockets. So we have to create our own UDP socket, and then we should connect to the NetD, the network interface. Now, if we try to build our ROM here, our build will fail because we have just hit a never allow. Now is the time to talk about never allows. As you can see, we're writing allow rules here. So allow our app to do this and allow our app to do that, but some parts of the system aren't meant to be accessed by everyone. So those parts of the system are covered by never allow rules. Lucky for us, when our build has failed, we can check the logs and find the exact line of our policy that hit the never allow, and also the exact location of that never allow with the file name and the exact line. So if we take a look at the actual never allow, it is located in domain policy file, so it's pretty generic. We can see that no domain except for domain net domain and some shady group of violators is allowed to access the netd to establish socket communication. If we will have another look at our policy, we can see that we have just tried to do exactly that. We have tried to access the netd, and this is forbidden. The logical question here, how can we fix that? Because we need our app to work. There are several ways to do that. First one, the most, the most easy one, we can actually add our type to the exclusion list. So if we add this line, and now it will say like, any domain except core domain, net domain, shady violators, and our app are allowed to establish socket communication. If we try to build our ROM now, it will work. But keep in mind that avoiding a never allow like that should be considered as a last resort. Only if no other option has helped you, you should consider doing that. And of course, changing the platform policies is not really the best way to avoid a never allow. Okay, so we won't be changing the system policies. What else can we do? Let's take another look at the never allow. You can see that there is some kind of violator grouping here. Can we utilize that somehow? Actually, we can. We can add a line to our policy that will mark our type with the violator attribute. So again, if we try to build our ROM, it will work. But this is not the best way to do that either, because you are creating a policy for your app, and you are marking it as a violator right out of the box. So I wouldn't recommend that as well. But there is another way. Let's take another look, and we can see that net domains are actually allowed to establish communication, which is kind of logical. And the correct way to avoid this never allow is to get back to your policy and add another line, which will mark your app with the net domain attribute. Now it will work, and this is the correct way of avoiding a never allow. Okay, so we have created our policy, we have built it, but still it doesn't work because it is not enough to just create a policy. We should make SELinux know about it. We should label our app with it. For this purpose, we should take a look at SEApp context file. Again, this is a plain text file. There are several context files in the policy sources, and their purpose is to label certain entities with certain security labels. So to make SELinux know about our policy, we should add this line to it. Again, it can look pretty complicated, but let me just dissect that for you. So we're basically telling SELinux that if it will see an app with platform signature, because we're building our app with the ROM, and with this package name, this app should be labeled with this security context. And if this app will create any files or folders, those files should be labeled with this security context. The level part, again, relates to the multi-level security. I will not cover it here. Okay, so now we have created a policy. We have told SELinux to use it, but of course there will be errors. So now it's time to learn about the debugging ways. First thing we need to do is we should add this line to our policy by this line, we are marking our policy, our type, as permissive. So all the system security will stay intact, because you can also disable SELinux whatsoever and put it into the whole permissive, fully permissive mode. But you can just switch your particular type to permissive. And your app labeled with your type will continue to work, and you will see many, or maybe not many, I hope not many, log entries with security violations. But it will still continue to work. So this is the ideal way to grab some debugging information. Also, there are some pretty useful shell commands. For example, you can change context of a particular file by mentioning the new context, the new security label. Also keep in mind that it will have to be the full security label here, not just the type name. And you have to indicate a particular file that you need, that you want to relabel. Also keep in mind that this change will not be persistent. So if you reboot your device, it will be labeled with the default security label that that comes with the default policy. But actually, you don't have to reboot your device every time, because there is also a restore context command. You can relabel everything by not mentioning any parameters. You can relabel a particular file, or you can relabel a particular folder recursively. So again, this command will make SELinux reload the security label of mentioned item, and after that, it will have its default security context, canceling any changes you might have made with change context command. Also, you can run context. So if you are starting some kind of process from ADB shell or another shell, you can also attach a security label to it. This is another pretty complicated looking line. This is an example of what you will see in the logs when you have run your app in permissive mode, and you will get some kind of warnings, and they will look like that. Actually, this is some random SELinux warning I've just picked up from my phone. And then you can see it is Tasker related, actually. But again, this complicated line can be pretty easily transformed into an allow rule for your SE policy. Let's see how we can do that. Of course, we will start with the keyword allow. Then we should take the calling context. In this case, you should take a look at asContext attribute and take the type part from it. So in this case, the calling context is untrusted app. Then you should pick the context that is being called right now. In this example, this is sysfs. Then you should add a class to it. So in this example, our untrusted app is trying to access some folder in the sysfs. And of course, you need to add the actual operation. So as you can see, it is not really complicated to transform a denial into a corresponding allow rule. There are also some command line tools that can make this kind of operation automatically for you, but I wouldn't recommend to use them because they just usually lack common sense. So they will attempt to write allow rules for basically everything. And like in this example, you don't actually need to allow untrusted app something more that it already has. So this is just an example. You don't have to write those kind of allow rules. And time to wrap up, I think. This was by no means a complete tutorial or a complete guide or complete anything, because SELinux is a pretty complex and pretty big topic. And I have just scratched the surface, really. But still, I hope that you learned something new today, guys. And if you have any questions, I'll be glad to answer them. Thank you very much.
Thanks a lot, Victor, for this complicated topic. Well, that was too much about security, and I was concerned about my security on my phone a little bit. Like, hey, what's up? Are you trying to hack or something? What's this? But it was really, I enjoyed the topic. It was really cool, and I hope that the watchers also loved it. And if you guys have any questions, you can ask it right now before tomorrow. And you said SELinux is quite complicated. I mean, so it has only to do with security, right?
Yeah.
Okay, so is it like is it used only for good things or bad things sometimes?
Again, let's talk about super user access. As you can see, it is considered as a security threat.
Yeah.
Which it is, obviously. But by default, SELinux is not affected by super user. Of course, you can change the system policy to allow super user to do anything. But again, by default, even if you try to switch SELinux to permissive mode by a shell command under super user privileges, it won't allow you to do that because changing SELinux mode is protected by SELinux.
Okay, so it clearly is safe to use, and we're not like it's like there is no possibility for like bad people to get it and use it for their advantages.
It is actually tied to the system partition.
Okay.
So if you are producing a mobile phone, of course you can write over allowing policy that will grant you some shady access to every part of the phone. But if you have just bought that phone, you cannot really utilize it. Well, you actually can, and there are some ways to extend the factory SE policy with additional rules. Like, for example, Magisk will allow you to do that. And I'm using that hack myself, actually.
Okay.
But again, it's not a big deal because you cannot change everything. You can just extend it a little.
Okay, so our phones are kind of safe.
Yeah, you can say that. And also interesting moment here, all the never allows that can fail your ROM build are compile time only. So if you have a compiled binary policy and you're trying to extend it with some hack, there will be no further never allows check. So you can add a rule that would be denied by a never allow, but after your policy has been already compiled.
Okay, that's cool. And just a question. I mean, I have a small question. I mean, because I heard, well, everyone heard the news like 2 years ago that uh, Google is trying to move to a new operating system.
Well, as a rumors, yeah, I've heard them as well.
Is that operating system still going to be? I mean, are you still going to be able to use the SELinux on that operating system, or is it like something completely different?
I think not, because the new operating system won't be using Linux kernel in it, as I have heard, because SELinux is tightly coupled with Linux kernel.
Yeah, yeah. So it's
So
not.
as long as the Android will continue to use Linux kernels, it will continue to use SELinux.
Okay, so the new system is based on something else.
Yeah, I've heard so. Some kind of real-time kernels or something.
But no one knows when they will drop it. Because,
Or even if.
yeah, we know that the symmetry of Google is really big, huge, and
Yep.
maybe they would just kill
And
it
it's
again.
growing.
Yeah. The purpose, if I still remember, was just to to give like the freedom. It's like the new operating system is gonna be more of like a good place for hybrid applications. Like for example, that hybrid applications can easily, like for example, get access to hardware without using some kind of packages or writing some like
But wait, we
native code. Or,
already have PWAs. Just kidding. You can look
yeah,
at it
yeah.
from the point of view that with the new OS, Google can actually try to get rid of the Android legacy, because Android is old and it's never changed so drastically. So we
Yeah.
can still use Java to create our apps. We still use JVM for our apps to run. We still have Unix kernel,
Mm-hmm.
and maybe it's just an attempt to get rid of it.
Is
With
this
all
is
the with all the experience that Google has gathered over the years.
Mm-hmm. How old is Android? Like 22?
Uh,
20?
the first Android was back in 2007,
2007. So
something like that.
it's about 13 years so far.
Yep.
But it was before like Google, I mean, buy it or whatever it is.
Yeah, that was the very first Android release before the company was acquired by Google.
Okay.
That's why Andy Rubin is called the creator of Android.
Yeah, I still remember in 2012 I had a 2011, like a neighbor just gave me a smartphone called Android, nothing else. I still remember it. Yeah,
In
so
2012, I think I rooted my phone for the first time.
okay, that's cool. At that time, I think I saw the first Android original phone directly. It's not Samsung or anything. It was cool. It was big, also. So, thank you again for today's like
Station.
talk, and it was really cool. Thanks for being our host today, and hopefully people enjoyed it, and people who didn't understand it, I mean, kinda gonna give it a try and see what they can do and build and create and innovate using the SE Linux. Thank you again, and see you again.
So, hey,
See you again in the next topic soon. And thank you guys for watching, and see you also in the next few days. Take care.